Hi there, this is question 2 from the trigonometry assessment. My class did this the other day, but you're more than welcome to have a look and see how you get on. Probably worth pausing the video and then seeing how you get on with when I go through it. Starting with question 2a, we have to sketch the graph of arc sine of x. This is the inverse function of sine x, and any inverse function is just a reflection in the line y equals x. So I'm just going to start off by sketching out sine x, and I'm just going to do sine x between 90 and minus 90. The reason for that is that I can see here that it's asking me to do arc sine between minus 1 and 1, so I'm only going to need to go that far. If we're reflecting this in line y equals x, then the graph we're going to end up with is going to look like that. That shape should be sufficient, and I just get rid of our sine x. That's what we're looking for. And because it's an inverse function as well, it means that the axes will switch around, the x and the y. So instead of 1 being on the vertical axis, it's on the horizontal, so it goes from minus 1 to 1. And then on the vertical axis, again, these will switch around, so we end up going up to 2 pi and down to pi over 2 in both cases, positive and negative pi over 2. For part B, we're asked to sketch y equals sec x. If you've watched the previous video, you remember that sec x, the third letter is c, so that's the same as 1 over cos. So what we're going to do is take our values of cos and do the reciprocal, 1 over all the values of cos. Now when x is 0, cos is 1 over 1, which means we know that our sec graph is going to go through 1. When we get to pi by 3, which for those not as comfortable with radians, that's 60 degrees. Cos of 60 degrees is a half, but we're doing 1 over cos of 60, so 1 over cos of pi by 3 will actually end up being 2. And similarly, if we do minus pi by 3, then cos comes out as minus 2. And we get that shape there. It asks us to state the coordinates of the endpoint, so it's important that you make sure you write those coordinates in clear for the examiner to see. And there we go. So that's our graph of sec x. It then asks us to use the trapezium rule with 5 equal spaced ordinates. 5 equal spaced ordinates means we're going to split, we have 5 points. So we're going to have these 5 points here. So that's going to be minus pi over 6, 0, and pi by 6. Be careful, 5 ordinates means 4 strips, rather than getting confused and trying to split it into 5 strips. So we're going to have these strips here for our trapezium rule. Now the trapezium rule is in the formula booklet, should you be sitting the exam, and it's under the C2 section. So you're more than welcome, even in a C3 exam, to go back and have a look at that. And all you have to do is plug the appropriate numbers in. So for our values of x, we've got minus pi by 3, minus pi by 6, 0, pi by 6, and pi by 3. And if you put those values into sec x, you get obviously 2 at this end, 2 over root 3, that's 1, that's 2 over root 3, and that's 2. And then you need to put those all into the formula for the trapezium rule. So what we're actually trying to find is the area from minus pi by 3 to pi by 3 of sec x with respect to x, and we're going to estimate that using the trapezium rule. So we end up with pi by 6, because that's the width of each strip, and then we've got the first height, the first ordinate if you like, and then plus 2 lots of all the ones in between. So we're going to have the values of minus pi by 6, 0 and pi by 6, and then plus the other 2 on the end. And that gives us 2.78 to 2 decimal places. Feel free to check. And that's the answer that we're after.